All right, so today what I want to look at is take a closer look at solving logarithmic equations. We spent a significant amount of time solving exponential equations, but I wanted to spend a little bit more time because these ones you have to be careful about your domain. Okay? The domain of the logarithmic function is that the argument has to be greater than 0. Okay? So the argument has to be greater than 0. That means when you're identifying the domain, whatever that argument is, in this case, it's the square root of x minus 8, that has to be greater than 0. Okay? So in order for the radical to be greater than 0, what's inside the radical has to be greater than 0. So for this equation, whatever answer we get, we have to have x greater than 8. That's the domain for our function. Okay, so if we were to solve this and we got x equals 3 for some reason, we would say that there's actually no solution for it. Okay? Now, when I give you an equation, I'm not going to necessarily ask you, hey, what's the domain of this for x in this equation? However, when you're told to solve an equation, you need to check to make sure that the results you get are in the domain. Okay? So, now, when we solve this, though, we covered this case yesterday where we have a logarithm on one side of the equation. And how do we handle that when we have a log on one side of the equation?
You take a log of the other side?
No.
Like the change to base 10.
You convert it
log
to
of
x.
that
No.
divided by log of the base.
Yeah.
That's a change of base, right?
Well, but then we'd still have, I mean, you're talking about doing log base 10 of root x minus 8 over log base 10 of e, but that really didn't get us any closer to solving the equation, right?
Just, do you convert it into exponential?
Yes, that's what we've got to do. We've got to convert this to an exponential. Our base, like we said, is e. So when we convert this to an exponential, e is the base of our exponential. What's the exponent? 5. And e to the 5th will equal,
Square root of x minus 8.
there you go, square root of x minus 8. All right? All right, so to finish solving this one, now it's just basic algebra. But one thing I will say for this one particularly, you know, what's our next step here?
Square both sides.
Yeah, we got to square both sides, okay? If you square e to the 5th, what do you get? E to the 10th, all right? You can leave it as e to the 10th. If you punch that into your calculator, you're going to get scientific notation, and that's going to make it challenging to do our last step, which is to add 8. Okay? So I'd rather you just leave it in terms of e. Our answer is x equals e to the 10th plus 8. Is that bigger than 8? Yeah. It's a lot bigger than 8. Okay? So this is in the domain, but there's our solution. Okay? Does that make sense?
Yeah.
If there's like, in what like scenario is it where you have two different inequalities and you have to choose?
That's where you have more than one logarithm in the equation. Okay? And actually, our second example here, if you take a look at this one here, we have the log of 4x. So what is x allowed to be for that one?
Equal to the
4x has to be greater than 0, right?
Yeah.
So x has to be greater than 0, all right? Now, that's just one of the logarithms, though. The other logarithm, the argument is 12 plus radical x, okay? So 12 plus radical x has to be greater than 0. Okay? Now this one could be a little bit tricky, okay? Because notice here, if I subtract 12, root x has to be bigger than negative 12.
Oh.
That's a big.
Okay? Now if I square both sides, the two things happen. One, the negative becomes positive, obviously. But also, if I squared both sides, I'm messing with the degree, right? And anytime we mess with the degree, that introduces the possibility of
Negative. Huh?
extraneous roots. Okay? Remember when we dealt with radical equations before, if we squared both sides, you know, we had to check our answers, okay? So in this case, this is the type of thing where I'm not asking you for the domain here. I'm asking you to solve the equation, but you need to check your results to make sure that they actually work. Okay?
What do you mean by work? Like, are within the domain?
Well, there's two things. Number one, are they in the domain? If they're in the domain, does it actually make the left side equal 2? Okay? That's what an extraneous root is. Remember, an extraneous root happened when it did come out and everything worked just fine, but if you plugged it back into the original equation, it actually didn't come out equal. And that happened because we messed with the degree. We're going to have to square things at some point to get rid of this radical. Okay? And anytime we're squaring stuff in an equation, we're messing with the degree of that equation, and that could introduce those extraneous roots. Okay? So, we can keep solving this one. We just have to be careful when we get to the end to make sure our answers actually work.
For the x is greater than negative 12 or for the whole problem?
For the whole thing. Okay?
Can you do x is greater than 24? I mean 144?
Well, that's the thing. If x has to be greater than 144, if I plug 0 in for x right here, I get something that actually works, right? For this logarithm. And that's where it gets a little bit tricky. That's why I said, don't worry so much about trying to state a domain for the entire problem. But if you identify this, you can then, at the end, check your results. Okay?
I'm lost.
Yeah.
Well, let's work on solving it. I think it'll make more sense once we get there, okay? How would I go about solving this equation?
Add log 10.
It'd be log.
That's my
Log is
question.
10 of 4x divided by 12 plus x squared.
There we go. If you have multiple logs, you want to put them together into one log. Okay, and with subtraction, when we put logs together, this is what we covered before break,
It's dividing, right?
is division, okay?
So it'd be
So it's 4x over 12 plus root x. And that equals 2, okay? Remember, that's because when you divide, you subtract exponents, and logs are exponents, right? So if you see logs subtracted from each other, you combine them as division. All right? So now what do we have to do?
Well,
now we should try to
figure it out.
find the domain, like for extraneous roots.
We don't have to mess with domain until the very end at this point. How would we keep solving this one though?
Log it out.
Raise the power.
Make it into an exponential function.
Yeah, make it into an exponential function. So, what's our base?
10.
10 to the
Second.
second equals,
4x over 12 plus root x.
there we go. Okay?
So then 100.
Yep, that's 100. We're going to multiply by our denominator. So it's now 1200 plus 100 root x equals 4x.
Wait, well, you just multiplied by.
The denominator. Okay.
So you just do 12. Yeah.
Okay. So now I have an equation that has x's and square roots of x's in it. So how do I go about solving this? How do we solve an equation that has x's and square roots of x's?
Quadratic, I don't know.
Wait, what?
I was right, quadratic for a thing.
Yes, it's the quadratic thing,
Quadratic.
okay? But we don't have a quadratic, do we?
Square it. We square, yeah, we square, yeah, we do. Because we square both sides and then we get an x squared and then 1x and
If
then.
he's making a face, then it's not
No,
right.
but I'm gonna prove my point.
Well, here's the thing. We do want to use the idea of a quadratic. But if you were to square it, you'd have to FOIL the left side and you would still have radical x's in there, okay?
Why?
Well, because you FOIL, all right? If you squared the left side, it would be 1200 plus 100 x, root x times 1200 plus 100 root x, okay? So you'd have root x's once you FOILed. However, notice what we could do. When you're solving a quadratic, what's the first thing you do?
You determine what the A, B, and C are.
GCF.
Before you even do that,
GCF.
Put it on the same side.
Factor.
there we go. Put it all on the same side. Let's get this equal to 0.
Way to go, Ken.
4x minus 100 root x minus 1200. Okay? Now we can talk about factoring and stuff. Why am I allowed to treat this as a quadratic though, even though it's not a quadratic?
Because
Because it's still like
two
the
quadratic.
radical x
Oh, I get
squared.
it.
It's still to the next power.
Okay, good.
That's all.
Check this out. This x, I could write it as the square root of x squared,
True, you're right.
right?
Wait, why?
Because that's still.
Well, because that's x, right?
Oh.
The square root squared is x. So notice here, if I treat this as a quadratic, I have this middle variable of a root x, and the first term has that same root x that is squared, okay? Now, some people don't like thinking of it that way. Some people like to use substitution a little bit. They'll say, we're going to let
That's wrong.
y equal the square root of x. So they'll rewrite the equation as 4y squared minus 100y minus 1200. And there you can see the quadratic.
Yeah.
Okay? Here's the one thing to be careful of if you actually do the substitution. And that is, we're not solving for y. We're solving for x. So you need to make sure you finish at the end. Okay? Now, either way on this one, we can divide everything by 4, right? Right? We could divide by 4.
Why?
Yeah, yeah.
Because everything's a multiple of 4. So,
Yeah.
yeah, so we got 0 equals y squared minus 25y minus 300.
4 times 25.
Okay? Now, you can try a bunch of different stuff, but this one actually doesn't factor.
Yeah.
Okay, so what do we have to use if it doesn't factor?
Quadratic formula.
The quadratic formula.
I don't want to do that.
Okay?
Negative b.
So, good. Negative b, so positive 25, plus or minus the square root of b squared
Squared.
minus 4ac. 4 times 1 times a negative 300 is a negative 1200. So it's plus 1200
All over 2 and so.
all over 2. Now, what
1200 or 200?
1200 because it's minus 4ac. So now, whether you're talking about this being y or whether you see it as root x, either way, okay, that's what it's going to be.
And so, in your answer, would you write root x equals that?
Yeah, root x equals this, so then what we have to square the results here to get x.
Okay.
Okay?
So
So here we need our calculators a little bit.
you have to do both, like the plus and
Those
the
guys.
minus.
Yeah, we do need to do plus and minus. That's square root, okay? So some of you guys do the plus and some of you do the minus. Okay? Alright, what'd you get for the plus? Plus square root.
1,000. Is this right?
What just happened?
1,000,
I just died.
46.
1046.
No, sorry. 1,100.
Oh my God.
Wait.
Minus.
1,146.
Okay.
Subtraction.
And what's the decimal there?
0.5002.
Okay.
That's what
I
I
got,
got.
yeah, I got 33.86.
That's what I got.
Okay, so you did the minus and you got
But you
the,
didn't-
No,
I got
But that's what
33.86.
that's what
Yeah, that's
x equals, not x.
Oh yeah, we have to do
not
squared. We have to do
not
squared.
plus.
So why does it keep turning off?
okay? That's not what x is. That's what square root of x is, right?
No,
So then do we square both
No, yeah,
sides?
she's right. It's
She's
11,
right.
It's
She's
1146.5.
1146 is x.
After you squared it,
After
okay,
you square it.
I'm ashamed.
okay.
Yeah, no.
What did you get before you squared it?
Yep, 33.86.
Okay, so root x was 33.86 and x is 1146.5.
Uh-huh.
Okay. Alright, what's your other result when you do minus the square root?
78.5.
Okay, but you got negative, what was it, 8.8?
Oh, you told me I got it wrong.
I know which one you're doing.
Okay, now, all of you can do the quadratic formula. Let's look though at our results. Are our x's both greater than 0?
Yes. No, yes.
Are the square root of x's both greater than negative 12?
Yeah.
Yes. So, do both of these answers work as far as the domain is concerned?
Yes.
Yes. Alright. Here's the problem though. Let's plug these back into the original equation. Alright? I want some of you to plug in the 1146.5 on the left hand side. And I want some of you to plug in the 78.5.
Why would you even bother doing the domain? Why wouldn't you just jump right into plugging it back in? Because if it doesn't work with the domain, won't it not work when you plug it back in?
Yeah, if it doesn't work with the domain, it won't work when you plug back in, for sure.
So since we're looking for extraneous roots anyways, can't we just skip the domain thing and plug it back in?
You can if you want, but it'll save you a little bit of work if you like we got if we got square root of x is negative 15, okay, then we can we don't even have to test it out. Okay?
Does that say x is equal to 1146.5 and 78.5?
Yeah, approximately. Alright, so if you plug in the 1146.5, you may, because we rounded, you may get just slightly off 2, alright? But you'll notice here, if I plug in the 1146.5, I get 2. So that actually is the solution to the equation, okay? If you plug in the 78.5, x equals 78.5, you're going to get approximately 1.18, okay? So that obviously did not give us the result we wanted. Even though the domain worked, okay, it doesn't work in the original equation. It's an extraneous root. So therefore, we actually only have one solution to this equation, and that is 1146.5.
So x equals 78.5 is the extraneous root?
Yes.
Well, isn't it x equals negative 8.8?
No, square root of x was negative 8.8. X was the 78.5. Okay? So there's only one answer for this equation. Okay? Now, one of the reasons why you guys need to get really comfortable using your calculators, and I've been telling you this for months, okay, is because we are actually doing some in this unit that you cannot solve algebraically. Okay? For example, let's take a look at this equation here. if I have the natural log of x plus the natural log of x squared plus 4 equals 10, okay, I have two different logs, right? So what's the first thing that I want to do with these?
Eliminate that.
Eliminate that, how?
You could take the. You could do it. You can kept saying.
Do what?
Put it into exponential form.
Not yet.
This
Label
one,
that
how
as-
do you,
Wait for
You-
that.
A natural log
Log
of x times x squared plus 4.
Yeah.
There we go. We see the addition here. The addition here of logarithms means that we can multiply the arguments together, okay? Guys, listen, if you've got an equation that has more than one log, you need to put them together so that you only have one log. You cannot put it in exponential form until you have only one log. So you can see here, actually, the result of that is this. If I multiply those together, I have the natural log of x cubed plus 4x equals 10. Okay? Now, if I were to rewrite this in an exponential form, I would have what?
E to the 10th.
E to the 10th equals x cubed plus 4x.
Yeah, and how in the world are we actually going to solve that? Okay? Well, it's not a quadratic, it's a cubic, and we can't use the rational zero test because e is not a rational number, so we're kind of stuck, right?
You just have to put it into the calculator.
So here's how we're going to use our calculator. You have one of two options, depending on which tool you want to use. Both of them, however, involve graphing, okay? One of these is, if I take the two sides of the equation, I can graph those as two separate graphs, okay? So you'll notice here, I have the line y equals 10, right here, and I have the natural log of x cubed plus 4x. That's what this graph right here is. Okay, and of course there's an asymptote here at 0. Okay?
Wait, what do you plug into your calculator? Oh, I see.
Right here, my y1, I'm going to make the natural log of x cubed plus 4x, and my y2, I'll make the horizontal line 10. Okay?
So where'd you get? Oh, okay.
So now, if you hit second calculate, remember the trace button, if you hit second trace, it says calculate, and one of the options there is intersection, okay? And the intersection asks for first curve, second curve, and guess. We've done that before in the past some, okay? So, you do that, and you get the intersection to be the point x equals 27.98406 and y equals 10. So what's the solution to our equation?
How do you get it to?
27.98.
Yeah, x equals 27.98406.
You hit trace. You got it.
Second trace for calculate, and then one of the options there is intersection. It'll ask for first curve, you just hit enter. Second curve, hit enter. And then scroll over, it asks for a guess. So scroll over close to where the intersection is. Okay? And hit enter again, and it'll give you your solution. Okay?
It's not e to the 10, it's just 10. Yes, sir.
Alright, does that make sense? One alternative way is if I subtracted 10 from both sides, notice here, if I subtracted 10 from both sides, the whole thing equals 0. Now the nice thing about this is I only punch in one function. I'm going to put that natural log of x cubed plus 4x minus 10 into the y1, okay? So here's my y1 is the natural log of x cubed plus 4x, all minus 10. But now I'm not calculating an intersection because I only graphed one thing. I want the intersection of this graph with the x-axis because it's got to equal 0, right? So I do calculate, and one of the other options is zeros. And if you remember, that one asked you for a left boundary and a right boundary, or I think a lower and upper bound, and then a guess. Okay? But we've worked with that function as well in the past. Okay? So there's two ways of solving these. And by the way, on the test I do give you an equation that you cannot solve algebraically. You must be able to do this. Okay? So on your IP you can practice with this as well. Alright, I've given you a few to practice solving. Try them algebraically. If you're totally stuck, then you can try doing it with the calculator. Or obviously if the directions say use the calculator, then just don't bother trying it algebraically. Okay?
For a problem like this, do we have to show our work like on the test?
On a problem like this on the test, you would have to sketch the graph to show. But you've got your calculator. You would sketch the window, you'd sketch what you see on the graph.
So we'll know when we're supposed to use the calculator.
Yes,
When is the time?
Evan?
Next
If, like, I had where my intersection was off the window, and then I don't know if it couldn't find it because it was off the window or if I messed up.
It can't. It cannot find, hey guys, it's a good question. Guys,
We haven't done it.
if on your calculator you cannot see the intersection, your calculator will not be able to find the intersection. You have to zoom out until you can see it. Alright?
Alright.
So.
Thank you.